Hi, welcome back. Today we'll be learning the types of chemical reactions. Okay, so there are different types of chemical reactions, and the first one is combination reaction, and second one is decomposition reaction, third is displacement reaction, fourth is double displacement reaction, and the fifth one is oxidation and reduction reaction. In short, we call it as the redox reaction. So here in class 10 we just have to learn the types of chemical reactions in detail, that is combination, decomposition, displacement, double displacement, and the redox reaction, that is oxidation and reduction reaction. So the first reaction is combination reaction. So I've written A plus B gives C. That means you're having two substances. Okay, so I've taken one as A and the other as B. So they combine together to form another substance, a single substance, that is C. In short, I have written A plus B gives C. Okay, it is not strictly that you have to take only two substances. You can take more than two substances. Okay, so that means the definition of combination reaction will come like this: those reactions in which two or more substances combine to form a single substance, you call that as what? Combination reaction. Combine or else combination, or else in short that will come as a combination reaction. So we learn some examples over here. The first one is magnesium. Mg is magnesium plus oxygen, that is O2, undergoes combination reaction. So what you have to do is, above the arrow mark you have to write the name of the reaction. So I have written over there combination to give MgO. What is MgO? Magnesium oxide. So whenever you write a chemical equation, you have to balance it. So I've written 2Mg. What is the state? Solid state, combines with oxygen, that is in gaseous state, to form 2MgO, that is magnesium oxide. Okay, so this is an example of what? Combination reaction. This reaction we have learned in the beginning of the chapter that magnesium ribbon, when it is burnt, that is in the presence of oxygen, it gives what? Ash. With a dazzling white flame, it produces ash. What is that ash known as? Magnesium oxide. Okay, so this is the first example of combination reaction. Now we'll see some more examples. So here we come to the second example of combination reaction. You can see over there example 2, that is two molecules of hydrogen combines with oxygen, both are in gaseous state, to form two molecules of water, that is liquid state. So hydrogen combines with oxygen to form water, will come under combination reaction. Then the third, I have written over there carbon, that is in the solid state, combined with oxygen in the gaseous state, that is G, I have written G over there, to form carbon dioxide, that is also in gaseous state. Another example is hydrogen gaseous state combines with chlorine in the gaseous state to form 2HCl, that too is in the gaseous state. Another example is 2Na, that is two molecules of sodium combines with one molecule of chlorine to form two molecules of sodium chloride. The sodium chloride, that will be in the solid state. Then coming to the sixth one, that is Fe, in the solid state combines with sulfurous S. Okay, I've written sulfur capital S, and here this S is the state, that is solid state, to form FeS, that is also in solid state, and the name of the compound is iron sulfide. Iron combines with sulfur, sixth one I am telling, that is iron combines with sulfur to form iron sulfide. Then the ninth one, that is CaO, solid state, that CaO in solid state, that is lime, a quicklime. It combines with water, that is the liquid state, to form calcium hydroxide, that is the slake lime. This equation is very important that we learn in detail now. So the seventh equation for combination I have written, The quicklime, a lime, calcium oxide is CaO, combines with water, that is liquid state, to form calcium hydroxide, that you call it as what? The slaked lime. So in detail we'll see the ninth example, that is I've written calcium oxide combines with water to form calcium hydroxide. That is the first chemical equation I've written. And above that I've written whitewashing. That is, these two examples are the reaction that occur during whitewashing. So here, when you take quicklime, it's in the powder state. Quicklime is calcium oxide. When you mix it with water, you get calcium hydroxide, that is the slaked lime. So during whitewashing, what they do is they take the powder calcium oxide, mix it with some amount of water, and you will get slaked lime, that is calcium hydroxide. And when you touch it, you can feel that it is slightly warm. That means it is exothermic. Some amount of heat is being produced. So when this chemical equation is given, what are the type of kind of reactions, chemical reactions that occur? You can write one is combination and the other one is it is exothermic in nature because it releases large amount of heat energy. The next one is slaked lime. So on mixing that white powder, that is the quicklime, with water, you are getting calcium hydroxide. Now what they do is they whitewash on the wall. Okay, so what they are using, they are on the wall they give a coating of calcium hydroxide, that is in aqueous state. You can write the state over there, AQ. So what happens is that in the atmosphere there is a large amount of carbon dioxide, and this carbon dioxide will reacts with calcium hydroxide to form the solid mass, that is calcium carbonate and water. After whitewashing, when you touch the wall, you can feel that it's slightly wet, but after a few hours, the next day when you touch it, you can feel that it's little bit solid with less moisture content, nil after so many days. Okay, so what is that solid matter that is present on the wall? That is calcium carbonate, CaCO3. So these two equations you have to write, and in detail you have to write when asked for whitewashing. Okay, so in the first equation, it is exothermic in nature. Okay, mixing it with water, quicklime, on mixing it with water you get calcium hydroxide. And the second one is calcium hydroxide combines with carbon dioxide present in the atmosphere to form a solid mass, that is calcium carbonate and water. Hope it's clear. And if you have any doubts in the given examples of combination, do let me know in the comment box. Coming to the next three examples of combination reaction, I've written over here NH3. What is NH3? Ammonia gaseous state combines with HCl, that is hydrochloric acid in gaseous state, to form a solid mass, that is NH4Cl, that is ammonium chloride, that comes under combination reaction. Then again I am taken over here 2 molecules of carbon dioxide combines with 1 molecule of oxygen. Both are in gaseous state to form 2 molecules of carbon dioxide, that too is in gaseous state. And coming to the 10th, the last example of combination, that is 2 molecules of SO2. What is SO2? Sulfur dioxide combines with 1 molecule of oxygen to form 1 molecule of SO3, that is sulfur trioxide. All these are balanced equations, so you can learn it directly. Okay, all the 10 you have to learn. So this is about combination reaction. So what was the combination reaction? 2 or more substances combine to form a single substance. Here 2 substance, 2 substance, 2 substance, they combine together to form a single substance. Thank you. Coming to the second one, your second reaction, that is decomposition reaction. I've written here C gives A plus B. What does that mean? I have a compound C which splits to form, or else you can say it decomposes to form 2 substances. I've written over there A and B. So C is a compound that splits to form two simpler substance, that is A and B. So or else you say that to be a decomposition reaction. So definition is that those reactions in which a compound splits up into two or more simpler substances. Going back here, I'll repeat. You have a compound C, okay, which undergoes decomposition reaction to give simpler substances A and B. So here different types of decomposition reactions are there. If the decomposition, if it happens in the presence of heat, so I've written over there that to be a thermal decomposition. And if the decomposition happens in the presence of electricity, then that you call it as electrolysis. And if decomposition happens in the presence of light, so here light can be in the presence of bulb, or it can be in the presence of a sunlight. In that case, you call that decomposition reaction as photolysis. So three types are there: thermal decomposition, second one is electrolysis, and the third one is photolysis. So in detail, we have to learn the decomposition three types: thermal, electrolysis, and photolysis. So here we have two equations from decomposition reaction. First, I've written calcium carbonate, that is limestone, CaCO3, which is in solid state, undergoes, that is in the presence of heat. The heat you can denote by this triangle. Will give you the products calcium oxide, that is in solid state, and carbon dioxide in gaseous state. I'll repeat. The limestone undergoes decomposition reaction in the presence of heat to form the compounds calcium oxide and carbon dioxide, that is CO2. So whenever you write a chemical equation, you have to keep in mind, you have to write the name of each compound, you have to write the state, okay, and also the method that is used for that reaction. That is it in the presence of heat, is it in presence of light, is it in the presence of electricity? In sometimes we need some catalyst at specific temperature. So everything has to be written in the chemical equation that you are writing. Coming to the second equation, you are having two molecules of FeSO4. You can see over here FeSO4, that is solid state. The name is ferrous sulfate. What is the color of that? Green color. Or else you have the name as iron 2 sulfide. Okay, you have to write the Roman 2 within bracket. Then in the presence of heat, that is it undergoes thermal decomposition to form the products. What are the products that are formed? Fe2O3, that is in solid state. You name it as ferric oxide, iron 3 oxide. What is the color of that? Brown color. And with the elimination of two gases, that is SO2 gaseous state, that is sulfur dioxide. I'll just write 1 minute. Okay, I have written over here, that is SO2, that is sulfur dioxide, and SO3 is in gaseous state, that you name it as sulfur trioxide. Okay, so here I've written something in circle. What is that? SO2 will give you the smell of sulfur. So in this reaction, that is ferrous sulfate undergoes thermal decomposition. It's denoted by the triangle. To form the compounds, we have to form the simpler substances, that is Fe2O3, ferric oxide, sulfur dioxide, that is SO2, SO3 is sulfur trioxide. So I have written both the equations over here. Okay, make sure that you learn all the equations. So you might be having a confusion how to learn. Is it to just memorize? No. What you have to do is, you just have to write in a piece of paper. If you have some rough book, make it a practice that you write it 3 times, 5 times, and then just recollect and then write it once without seeing that. Okay, and what you do is, alternate days, you just have to revise it, again revise it, then it will be easy for you if you get a starting of the equation. What are the compounds? Suddenly you will get the answer. These are the products. Okay, thank you. If you have any doubts. So in this electrolysis of water, here I've written the equation 2 molecules of water. Okay, so in this reaction, if you take water only, this reaction, a decomposition reaction, is impossible. So what we have to do is, here I've taken the setup like this. I've taken the water inside. This water is acidified. What do you mean by acidified water? That is, water has to be mixed with some drops of hydrochloric acid. That is dilute hydrochloric acid or else dilute sulfuric acid. Okay, so that this water will become acidified. So here in this equation, that H2O, that is the water in liquid state, this is the acidified water. Is that clear? It undergoes decomposition reaction in the presence of electricity, or else in short we give the term that is electrolysis of water to form two molecules of hydrogen and oxygen. Both are in gaseous state. Liquid undergoes decomposition to give two gaseous compound, that is hydrogen and water. But here we need to learn in detail. So here I have the stand. I have a setup like this, okay, in which I have taken an inverted glass bottle, and on the mouth of it I have the rubber cork connected by means of, these are the carbon rods, okay, connected by means of wire, by means of a switch to a battery, that is 6-volt battery. And when you switch on, what happens? Chemical reaction will take place. So you know that here I've taken two inverted test tubes, okay. So as soon as the switch is on, the chemical reaction takes place, and you can see that in here some bubble formations are formed. Okay, why does this happen? Do you know the answer? Yes, we know that during electrolysis of water, I'll show you the equation, it splits to form the simpler substances, that is hydrogen and oxygen. What are they? They are the gas. You can see till here water is there, here also, and from there it undergoes the electrolysis, in which the bubbles means gas formation. And here in this compartment, in the first tube, you can see a larger space, vacant space, when compared to the other. In this equation, it's given that two molecules, two volumes of hydrogen, and one volume of oxygen, one molecule of oxygen. So which is bigger? 2 moles, 1 mole. 2 molecules, 1 molecule. 2 is greater, right? So that means here in this diagram, that is the 2D figure I've drawn, here the gas that is accumulated is hydrogen. I've written over here, and the smaller space, only 1 volume, that will be the gas that is accumulated is oxygen. Okay, so this is the experimental diagram which we have drawn in 2D. So how will you check whether the gas, which is the gas that has been collected in one test tube is hydrogen and the other is oxygen? What you have to do is you have to bring a burning splinter. Neto, you have to bring a burning candle near both the test tubes. Okay, what you have to do is you just have to take the test tube and you have to bring a burning candle near to both the mouth of the test tubes. If it burns with a pop sound, okay, if it burns with a pop sound, that means it will be hydrogen, and the other one will be oxygen. How to check for oxygen? You know that oxygen is a good conductor of what, or else you say that it is good for combustion or else combustion. It enhances burning, whereas in case of hydrogen it will burn with a pop sound. So from that you can identify which is the test tube that has hydrogen and the other test tube will be the other gas, oxygen. Now here I have written a ratio, that is the ratio of hydrogen and oxygen that is being collected over here. The volume ratio of hydrogen and oxygen will be 2:1. So you have to be very careful while reading the question. Sometimes they may give what is the ratio of oxygen to hydrogen. Okay, here I've written hydrogen to oxygen ratio is 2:1. So be careful when you read the question, whatever they have given. If the question is ratio of hydrogen to oxygen, 2:1. If the question is from oxygen to hydrogen ratio, 1:2. Okay, so be thorough with hydrogen is to oxygen is 2:1 ratio. So this is the electrolysis of water. Is that clear? So if you have any doubt, you can do post and comment if you understood. Yeah, if you have any doubt, yeah, if I need to improve. So from my side also, I will also do a bit learning. Okay, and from your side also, if you feel that you have some doubt regarding an experiment, you can just put a message. Thank you. Coming to two more examples from decomposition reaction. Here, two molecules of sodium chloride, and that sodium chloride, it is in the molten state. In the presence of electricity, that is, it will split to form two molecules of sodium and chlorine. Sodium is the solid state and chlorine is gaseous state. Molten sodium chloride is taken. That equation is also important. Coming to the third equation for decomposition reaction, I am having two molecules of molten aluminium oxide. In the presence of electricity, it forms four molecules of aluminium, that is in the liquid state, and three molecules of oxygen. So here you are having the molten aluminium oxide. It undergoes electrolysis, or else in the presence of electricity undergoes decomposition reaction to form aluminium metal. Both these equations are very important. Okay, so in electrolysis you just have to learn three, that is the electrolysis of water. You have taken molten sodium chloride and molten aluminium oxide. Okay, and one more thing you can come across is that these reactions are decomposition reactions, right? And these decomposition reactions are opposite of combination. In combination, what happens is that two or more substances, they combine together to form a single compound, right? In this, what happens is a single compound will split to form two or more simpler substances. So you can say decomposition is reverse of combination reaction. We have one more decomposition reaction, that is in the presence of sunlight here, bulb. We'll do that also. Coming to the next decomposition reaction, that is the reaction that happens in the presence of sunlight here, bulb. So here equation is two molecules of silver chloride. Silver chloride is having white color, and it undergoes decomposition reaction in the presence of light to form 2 Ag. What is Ag? Silver, which is in the solid state and it is grayish white in color, and chlorine gas, yellowish green color. So here in a petri dish I have taken some AgCl, that is silver chloride, in the presence of sunlight. What happens when exposed to sunlight? It undergoes decomposition reaction to form AgCl. It forms silver and chlorine. And the other one more equation I have written over here, silver bromide, pale yellow color. It undergoes decomposition reaction in the presence of light to form two molecules of silver, that is the solid state having grayish white color, bromine, which is having the red brown color. Both these equations are used in the black and white photography. Okay, so you can see over here, silver chloride will split to form silver and chlorine. Silver bromide will split to form Ag and Br. So most often question comes as, why can't silver chloride and AgBr be stored in any bottle? Why it is stored only in dark bottles? Reason is that it will come in contact with sunlight here, bulb light, so that it undergoes decomposition, so that compound will form the simpler compounds. To to restrict that reaction, what we do is we store AgCl, AgBr, that is silver chloride, silver bromide, in dark bottles. Okay, so that question also is very important, right? Make sure that you learn along with the topic. Whichever equation you are having, if there is any application based also, that also is important for you to learn. So today we have learned in the presence of heat, then electricity and light. Do drop your doubts. You can message your doubts in the comment box. Hope it's clear. So I've given the question, silver chloride, silver bromide, why it is stored in dark bottles. Okay, just now I have explained. You can go back and just see why it has been stored in dark bottles. Okay, if you have understood, just drop your answer in the comment box. Thank you. Now let's see the uses of decomposition reaction. Okay, so first one is that decomposition reaction of, you're having naturally occurring compounds like chlorides and oxides. Okay, so naturally occurring compounds of chloride and oxides, in the presence of electricity, what happens? It will extract metals. So the one purpose, the one use of decomposition reaction is that the naturally occurring compounds like chlorides, oxides, in the presence of electricity can extract metals. Second one is during digestion of food. You know that the food may be rich in starch, may the proteins. Okay, so the food that is rich in starch, what happens? It will be converted, it undergoes decomposition to form simpler sugars, that is glucose. Starch undergoes decomposition reaction to form glucose. Proteins undergoes decomposition reaction to form amino acids. This all happens during the digestion of food. So here uses of decomposition reaction I have written two, that is the extraction of metals from the naturally occurring compounds like chlorides and oxides, and number two is you will get glucose and amino acid during the digestion of food, which is a decomposition reaction, that is starch will be converted to glucose and proteins will be converted to amino acid. So these are the things we have to learn from the decomposition reaction. The first one was thermal decomposition, second one was electrolysis, and the third one was photolysis, or else if it is in the presence of light, it undergoes decomposition reaction. And last, that is the uses of decomposition reaction. Make sure that you read your NCERT textbook also. It's very important. Apart from the theory that you're getting, you have to read each and every page. Each and every line is important, as well as those written in the boxes is also important. You have to read. Don't skip any of your activities that is given in the textbook. Read each and every activity. There are many questions. If you are not getting any answer, what you do is you just type me in the comment box. I'll let you know, or else I'll make you understand how that process occurs.